Hi everyone, I am Pravalika from CSCT. Today I am going to explain about Ruby Laser. The introduction of Ruby Laser. Ruby Laser is a solid-state 3-level laser system developed by H.G. Maiman in 1960. It produces pulsed laser and the pulsating time is 10 nanoseconds. It is useful for various industrial applications like surface hardening, drilling of high-quality holes, pulsed holograms, etc. The main components of Ruby Laser are active medium, Ruby crystal rod, pumping source, xenon flash lamp, optical resonator, arrangement of silver polished mirrors on either sides of the Ruby rod. Now let's see the construction. The schematic diagram of Ruby Laser is shown in this is the figure of the Ruby Laser rod. Ruby is taken in the form of a cylindrical rod of about 4 cm length and 0.5 cm in the diameter. Ruby crystal is basically Al2O3 in which aluminium ions are replaced by chromium ions, which will play main role in emission of laser beam. For effective lasing, chromium is doped about 0.05% of chromium ion. A xenon flash tube is arranged around the Ruby rod, which supplies a white flash of light to active medium to achieve population inversion. Only a part of the flashlight is used for the pumping the chromium, while the rest heats up the apertures. A cooling arrangement is provided to keep the experimental setup at normal temperature. The two ends of a ruby crystal are grounded and published, and one face is silvered and one face is silvered to achieve 100% reflection, while the opposite face is partially silvered to make it semi-transparent. Here is the working principle of Ruby Laser rod. First of all, to know the working principle, we have to know the diagram of the how it plays a role. So this is the figure of energy levels and transition in a Ruby laser. Initially, chromium ions are at the ground state even. When xenon flash lamp switches on, the Ruby rod is irradiated by the flashlight. The chromium ions are excited to E3 level, which is pump level. So, the green component of the xenon light having a wavelength of 5600 angstroms is absorbed by chromium ions and they go to CR4, means to the upper level of the so you can see in the figure, so in the upper level of the energy levels. From the excited state E3, the atom spontaneously falls to the metastable state E2. So you can see the E2 which is upon the E1. So metastable state. What is metastable state means? The atoms will be stable at that position or at that level. So at the rate of 10 power 7 atoms per second by a non-radiative transition, at the rate of 10 power 5 atoms per second to the ground state E1 from E3. So from E3, the atoms will come to the E1, that is the ground state, in the power of 10 power 5 atoms per second. So the lifetime of chromium ions is more in E2 through E3, which gives population inversion between E2 and E1. A few chromium ions spontaneously fall from E2 to E1 by emitting incoherent photons. The emitted photons are reflected from the mirrors, which enables the stimulated emission from E2 to E1. Photons traveling along the axial direction are repeatedly reflected and amplified and emerge out from this semi-transparent mirror in the form of a strong laser beam. So what are the advantages of Ruby laser? The laser beam is red in color and corresponds to a wavelength of 6943 angstrom. Laser beam is emitted from the Ruby laser, which is visible to our eyes. So what are the advantages? Its output intensity is high. It has high acceptance band compared to other lasers. Okay, what are the disadvantages? The disadvantages are it gives pulsed output. So we get pulsed output, doesn't get stimulated output. So we doesn't get continuous output. So we only get pulsed output. So this is the drawback of the Ruby laser. And the second disadvantage is the efficiency is very poor. So this is about Ruby laser. Thank you.